Today's chapter review is for Math 2101, Chapter 4. If you're not on this book, then I hope this helps you. If you are on this book, then what I'm about to explain has to be clear to you. And if it's not clear to you, then it means you need Chapter 4, you need more time with Chapter 4. The topic is ratio and proportion. It's a crucial topic in math because everywhere you go in math after you've learned this, they'll expect you to remember it. And the way I explain it to students is, you move on to that next course and the next level up, they won't give you marks for being able to do this, but they'll take off marks if you can't do it. And it comes back all the time, especially in geometry, but also in other areas of math. Okay, let's get into it. First thing we're going to do is we're going to establish a ratio. So we have to know what a ratio is. A ratio is just a comparison of two numbers, really. So I looked up some distances on some maps, and I can see that the distance between Ottawa and Quebec City is 450 kilometers. The distance between Ottawa and Boucherville is 225 kilometers. I had to pick a city with a long name like this. Okay, there. 225 kilometers. So I can put these two numbers together, and I'm going to do that right now. 450 over 225, that's a ratio. I have a ratio which compares two numbers. It compares the distance between these two cities with the distance between these two cities. The next thing I'm going to do is I'm going to simplify the ratio, and I'm going to simplify it by 225, meaning I'm going to divide both of these numbers by 225. 450 divided by 225 is 2. 225 divided by 225 is 1. I have a 2-to-1 ratio. It means that the distance you have to drive between Ottawa and Quebec City is twice as far as the distance you have to drive between Ottawa and Boucherville. Now that was convenient, so I went on the map and I chose cities where the distances apart would give me a nice clean ratio, because this is an introductory discussion and I want it to be clear. I don't want to confuse things with weird decimals. So we have a 2-to-1 ratio. One of the things we can do is we can put this together upside down. And we would simplify it the same way, but we would get 1 over 2. Okay, there's a 1-to-2 ratio. It's really the same ratio. There's a 1-to-2 ratio between the shorter distance and the longer distance. There's a 2-to-1 ratio between the longer distance and the shorter distance. That's all that means. Now, that means there's two correct answers to the question, what ratio would you give between these two distances? But it also depends on how the question is asked. So if the question is formulated in the way that sounds like, show a ratio that shows the relative distances between Ottawa and Quebec City and Ottawa and Boucherville, they're sort of mentioning Ottawa and Quebec City first, so you would want to put that one first, and the 2-to-1 ratio would become the correct answer, and the 1-to-2 ratio would end up being not quite as good an answer. But often with ratio and proportion, because it really does work both ways, the questions don't specifically tell you how they want you to arrange it, and that means that different students can give slightly different answers and both be correct. So if you live in Ottawa, Quebec City is twice as far as Boucherville. If you live in Ottawa, Boucherville is half as far as Quebec City. So we have words that can go with these numbers and with this math. How about Rawdon and Val-David? Rawdon, Val-David. The distance is, where is it? 51 kilometers. How about Rawdon, Montreal? Rawdon, Montreal we have such long words in our place names in this province, is 102 kilometers. So you can see that the teacher has carefully selected towns again to try and get clean ratios. Well, let's put the two numbers together. I'll put the smaller one on the bottom again. So I have 102 to 51, and then I'm going to simplify by 51. And I get 2 to 1. I get the same ratio. So it just so happens that the ratio of distances between these cities, the closer drive and the further drive, is the same as the ratio of the distances between these other set of cities. So it's a contrived situation, I admit it. What we can do with this is we can establish a proportion. What's a proportion? A proportion is two ratios with an equal sign between them. Remember the meaning of the equal sign that was covered in the chapter reviews from the previous chapters in this book. The two sides have to be equal. So since we already know that a 2 to 1 ratio is the simplified version of this, and a 2 to 1 ratio is a simplified version of this, we know they're going to be equal. I've created a proportion because I know that these two ratios of distances are equal. So this is proportional. Knowing the meaning of the words ratio and proportion, proportional, is useful. So there's a lot of students who just ignore words like that and they don't want to remember their meanings, but the math is easier for the students who have words to describe it. So these are important words. Now, how can we write this? I'm going to get rid of some of this stuff. I'll keep this proportion though. A way of writing a proportion with words is to say 450 is to 225 as 102 is to 51. Students hate having to use words when they do math. So how is there a mathy way of saying this, saying the same thing? We can use the colon. 450 colon 225 equals 102 colon 51. So this is a ratio. Just like 450 over 225 expressed as a fraction is a ratio, 450 colon 225 is also an expression of the same ratio. And we read this out loud the same way that we wrote it here. 450 is to 225 as 102 is to 51. It works. Okay, now there are words for the four numbers in this thing. These ones in the middle, I'll use a different color of chalk. These ones in the middle are called the means. Mean implies the middle. And yet another color. These ones on the outside are the extremes. They are on the extreme outsides of the equation. So the means and the extremes are some more words in the lingo that goes with ratio and proportion. They're useful words. What we can do is we can multiply the two means and also multiply the two extremes. So I'm going to do that next. Starting with the extremes, 450 times 51 gives me, I did this ahead of time, I admit it. Where is it? 22,950. And then the means, 225 times 102 also gives me 22,950. Well, we kind of knew that was going to happen. The product of the means equals the product of the extremes, always, if the situation is really proportional. So now, that indicates something useful that we can do in math, called cross multiplication. So cross multiplication is doing exactly this, but normally we don't show it this way. We look at our proportion and we say, oh, 450 times 51 should be equal to 225 times 102. So what I did here was I multiplied the extremes and multiplied the means. And when I multiply them, of course, I'm getting this number, 22,950 has to be equal, of course, to 22,950. This sort of proves that cross multiplication works if your situation is really proportional. The way I like to express this to students who are just starting is to say, what is cross multiplication? It is top times bottom equals bottom times top. That's just what goes through my mind when I'm constructing this. But it's not just any old top and any old bottom. This top times this bottom, which means the extremes, has to be equal to this bottom times this top, which is the means. So I'm doing the same thing when I say top times bottom equals bottom times top, and build this as someone who's using the words means and extremes. Cross multiplication works, and it's extremely useful. It will work if the situation is proportional. Now, why would we do this? Now I'm moving on to another question. Why are we looking at the comparison between these two distances, which involved Ottawa, and these other two distances, which both involved Rawdon? Who would do this? Why are we in a math class learning to do such a thing? Well, I could try to think of an example like some traveling salesman who has to drive between all these cities all the time. He might have some reason to notice that this distance is twice as far as that distance. But it's not the best example in terms of answering that question, why would we do this? So I'm going to come up with a different example. And the different example involves a recipe. As always, I like to keep my introductory examples really simple so that the students can focus on what we're learning instead of all sorts of extraneous details that are part of a contrived situation. So my recipe will be a simple one. How about we have a recipe where we are combining 2 cups of marshmallows and 3 cups of rice cereal. Okay, that's a pretty simple recipe. This is 2 numbers that are being compared. We have a ratio. 2 over 3 is a ratio. I could write it 3 over 2 if I want. We already know that. But wait, what if we had 9 cups of rice cereal available, and we want to know how many cups of marshmallows do we need in order to be using the recipe? So in order to use the recipe, you have to do things that are proportional. Recipes are always proportional. And one quick way of solving this without even doing cross multiplication is I can see that 3 gets 3 times as big. 3 times 3 is 9. So I'll multiply the 2 by 3, and I'll get 6 cups of marshmallows. That is the correct answer. But that's happened so quickly and easily because this is an easy example. And the examples aren't always so easy. In fact, it's really about the number. The 3 and the 9 were really easy numbers to work with, so we were able to do a lot of this in our head. And a lot of people, well, nearly everyone, is constantly doing these little calculations in their head whenever they do a recipe. Because how often do you make exactly the amount that the recipe said? Sometimes you want to make double the amount, other times you want to make half the amount, and then you end up doing this math in your heads. Students don't even realize they were doing the math. They don't realize they were dealing with a ratio and a proportion, but they were. And that's because it's easy. But when you have an unusual number, it's not quite so easy. And it becomes useful to be able to solve it with cross multiplication. So instead of saying I'm multiplying both of them by 3, I'm going to solve this with cross multiplication. I'll go back to not knowing how many cups of marshmallows I need. And I'm going to multiply the means and the extremes. 3x equals 2 times 9. But My x isn't isolated. I want to isolate the variable, so I'm going to divide both sides by 3. These cancel. My variable is isolated, and x has to be equal to 2 times 9 divided by 3. So I could have simplified this on the way. I could have said, oh, 2 times 9 is 18. But this time I chose to just isolate the variable first. And then I simplify. 2 times 9 is 18, so we have 18 over 3, which is 6 cups of marshmallows. We have the same answer. We have the right answer. We knew we were going to get that answer. What if you have a more complicated number to deal with and it's a little harder to do it in your head? Like, where is it? What if we have 2.864 cups of marshmallows? Of marshmallows. I said 9 cups of rice cereal. No, it's marshmallows. 2.864. So we have to figure out how many cups of Rice Krispies. Not so easy to do it in our head this time. What do I have to multiply 2 by to get 2.864? And then multiply 3 by that number. I don't know if I'm comfortable with doing this in my head. I know a lot of students who wouldn't be comfortable with it. So we're going to solve it with cross multiplication. So we have 2x equals 3 times 2.864. Now before, I didn't simplify until the x is isolated, but this time I am going to start simplifying earlier. 2x equals, once I have two numbers on the same side of the equals, nothing's there except two numbers, I can combine them. So I'm going to combine them. 3 times 2.864 is 8.592. Now I'll divide both sides by 2. Cancel, cancel. X is equal to 4.296 cups of, in this case, it was rice cereal that I was being asked for. Remember to do this. This is applying your unit of measure. And now that shows different approaches to solving a proportion. With cross multiplication, here I kept on working to isolate my variable, my x, until it was alone, and then I did all the simplifications. Here I started isolating my variable, but as soon as I had two numbers that were together and could be combined, it did so, and then I kept doing my algebra. It doesn't matter. The student can do it either way. Either way they will get a correct answer, and either way they're showing their work. You know how teachers, math teachers always want you to show your work. I don't care so much how you show your work. Show it. Show me what you're doing. Because of course, one of the problems with this math is sometimes it's too easy. And when is it too easy? Once you realize, oh, I'm going to end up multiplying these two numbers and then I'm going to end up dividing the answer by that number. Then you can start pulling out your calculator and you can say 3 times 2.864 equals, divided by 2 equals, oh, I got my answer, 4.296 cups of Rice Krispies. And the student who does that often forgets to show how they got the answer. They did it all in the calculator. If this happens in an exam, when I'm correcting the exam and I see that answer sitting there by itself, I don't know what it looked like as you were punching the numbers into the calculator. I don't have a little time machine that allows me to go and observe you to see if you're really doing it right, or did you get that answer by pure luck? I don't know. So you have to prove it to me somehow. You have to write it down. Okay, so that is our review of Chapter 4 from the Math 2101 book. It's all about ratio and proportion, but we want to be able to go into detail and we want to get to know the language, the lingo that goes with ratio and proportion. Means, extremes, the word ratio, the word proportion, proportional, cross multiplication. You want to be able to talk about what you're doing. If you understood everything in this video, that's good. It means you understand a lot about Chapter 4 from this book. But if there are any things that you didn't understand that well, maybe it means you need more time with Chapter 4. Go into Chapter 4 and do the exercises that they give you to practice with.